Okay guys, as promised, this video on linear programming is going to be put online instead of in the class. And I remember last semester in my 1500 class, and my 1500 and my 3500, sometimes I was forced to put up videos for reasons that I couldn't control, like the weather. And there were a few times that I thought that the videos were fine. If students would take the time to sit down and really watch them, they certainly worked. But I think that there were times last semester that the video wasn't as effective as if we had met in class. Now, this is one of those situations where I think it's just opposite. I think the most effective way to present linear programming is online through this video than it would be in class. And the reason is I watch you guys struggle with the calculator, and some of you are very successful with the calculator. Students move at different paces with the calculator. This is going to the calculator exercises, or I'm sorry, the calculator keystrokes for this are going to be pretty complex. So this is going to give you, the opportunity to slow me down, to pause me, to stop, and stay up to pace with your calculator. So linear programming, in this lecture, there are going to be a couple of things that I want to do. First of all, I want to review inequalities. They play a major role in linear programming. And then I want to run through two examples of linear programming problems. So guys, from here on out, when you see LP, we're talking about linear programming. Now, guys, linear programming problems are just an extension of systems of linear equations. And this is the last topic that we studied just before your first exam. And by the time you watch this exam, your first exam will be behind you. And hopefully you did really well. So on that exam, you will have had the mathematical concept of systems of linear equations. Guys, remember the solution to these, if the solution exists, is an ordered pair, an x value and a y value. Guys, the difference in linear programming problems and systems of linear equations is these things are more realistic. Linear programming problems allow for us to treat things as constraints. Now, there are no constraints in a system of linear equation problems. For example, we solve for x, we solve for y, but there's no upper bound on the values that x and y can take on. I've told you guys that I owned a golf course at one time. Well, I had all sorts of constraints in running my business. First of all, I only had two people who mowed. They mowed for 40 hours a week. Some weeks it rained and they got less hours. So my constraint on the number of hours that I could have for mowing was less than or equal to 80 hours. Because again, they had 40 hours each and they weren't going to work overtime, and sometimes, we got rained out. I also had constraints on the number of carts. For example, if I had a scramble, I could only take so many players. So I had at that time, the number of golf carts that I had was 25. So the most number of golf carts that I could have out on the golf course at one time had a natural constraint to it in terms of 25. Now, if you figure that there's 2 players per cart, then the number of players, considering that nobody walked, and they didn't, okay, we had a lazy group of people, so the number of players would be less than or equal to 50. So we get into inequalities because they're a natural function of certain constraints that we run into in linear programming problems. Now, let's just look at a couple of linear inequalities. And let's just start out the first one, just a simple one variable. Now guys, there are 4 symbols for linear inequalities. These two deal with less than But this one right here allows for it to be less than or equal to. These deal with greater than. And this one right here deals with greater than or equal to. So we can say that 5 is greater than 3. We can say that negative 2 is greater than negative 5. But we can't say that 5 is greater than 5. That's not true. However, if we come in and put the equality there, then this is a true statement. Now, how do you remember, the whole inequality thing, greater than, less than, and so on and so forth? Some people say Pac-Man eats the bigger number. Yeah, whatever works for you. Man, I don't know. I just sometimes you just got to remember stuff. So maybe you've got your own individual triggers that make this stuff happen. If so, good for you. All right. So let's look at just a couple of simple examples. So if I say x is greater than or equal to positive 3, what I can do on this number line is I can bubble this in with a solid line and draw a line to the right of it, telling me that any number that I have in this shaded area over here, if you want to think about this as being shaded, is part of my solution set. So for example, somewhere out here is the number 927. Well, 927 when put in for x makes a true statement. It's in the solution set. However, if I choose a number that's not in the solution set, for example 1 is not greater than or equal to 3, so it doesn't make us a true statement, so again it's not in the solution set. Now, as you might imagine, these things can get a little bit harder. So we treat these pretty much, let me back up a little bit. Treat these pretty much as we do equalities, in that the things we do in algebra still apply. So guys, our solution set here would be x less than or equal to negative 1/3. So the same thing would apply. Look at our number line. Somewhere here, now that's just plain old ugly. So somewhere here on our number line of 0, -1, and +1, if we want x less than negative 3, that's going to negative 1/3. It's going to be about right here. Now, when we don't have the equal to in our solution, we designate that as an open dot. All right, let's move on a little bit to inequalities with two variables. And let's say we have something like this. Now, before I work this, I want to tell you a very, very, very important characteristic. Guys, when we multiply or divide by a negative, we must change the sign. And what I mean by the sign, that's vague. Let me change sign. We must change the inequality. I don't know why, but it's not letting me write down here. Okay, so we must change the inequality. Now, let me show you what happens there. Let's say we have 2 minus x greater than or equal to 7. Now the first thing we would want to do is we'd want to subtract 2 from both sides, leaving us with negative x greater than or equal to 5. Okay? Now a lot of times students will say, well, I have negative 2 there, why didn't I change the sign? Well, you're not paying attention. I said when we multiply or divide by a negative number. That's subtracting. That's adding a negative number. We didn't multiply or divide. But what I would need to do now is I'd need to come in and divide by negative 1 on both sides, or equivalently multiply by negative 1 on both sides. Because what I want to ultimately end up with over here is x and not negative x. Well, guys, this is going to give me on the left-hand side x, and on the left-hand side it's going to give me negative 5. Well, the principle that I just showed you says we have to change the sign when we do that. So instead of greater than or equal to, we have to change this to less than or equal to. Now, I've tried to show in symbols and theory and so on and so forth to students how, why that's the case, and it never seems to work. So at the end of the day, just remember that you have to do that. Okay? So if we run into something like 7 is greater than or equal to minus 3x plus 4. First thing we would do is subtract 4 from both sides. So on the left side I get a 3, and on the left side I get negative 3x. Guys, I've got to divide by negative 3 on both sides. So therefore I have multiplied or divided by a negative 3. So the end result here is going to be, on the left-hand side, I get a negative 1. I have to change the sign. And on the right-hand side, I get an x. So this is read that, and this is kind of weird because we read this way. This is saying that x is greater than or equal to negative 1. Now some students find that kind of hard to see it that way, and they find it more advantageous to change the direction. Put the x over here. Notice that the big part is going toward the x. So guys, when I rewrite that, the big part has to go toward the x. And then I have negative 1. So guys, these two statements right here are equivalent. They're saying the same thing. Negative 1 less than or equal to x is the same thing as saying that x is greater than or equal to negative 1. Because notice again, the open part right here is pointing toward the x. The open part right here is pointing toward the x. Okay, now, let's go back to the original problem here. 5x minus 3y less than or equal to 15. Okay? Now, first thing I'd want to do is I would want to think about this and getting it into y equals mx plus b. But we are no longer looking at equalities. We're looking at inequalities. So we're going to end up with y equals mx plus b, but instead of an equal sign here, we're going to have one of these. Okay? So 5x minus 3y less than or equal to 15. Now I want to subtract 5x from both sides. On the left-hand side, I'm given negative 3y. Do I change the sign? Have I multiplied or divided by negative? Nope. And on the the right-hand side, I have negative 5x plus 15. Now I've got to divide every single term by negative 3. Now have I multiplied or divided by a negative number? Yes, I have. I just divided everything by negative 3. So the left-hand side is going to be a y. This has to change. This term right here, a negative divided by a negative is a positive. And 15 divided by negative 3, negative 5. So guys, our slope is 5/3. And our intercept is negative 5. Now, I'm writing this down because I'm getting ready to leave this screen. Now, guys, what I want you to do now is I want you to grab your calculator. And I want you to go over here to y equal, and I'm going to show you how to plot an inequality. Now, the first thing we need to do is clear out any kind of junk that we've got in there. And let me show you something else you probably need to do. It may or may not affect the results. If you go second function up to stat plot, I would come down to number 4, which says turn all the plots off. Now, I've already done that, but some of you maybe haven't. So I would hit number 4, which turns the plots off, and then I would hit enter to complete that, kind of complete the transaction, okay? Now we'll go back to y equal. Now, anytime you put in a fraction in these things, put your fraction in parentheses. Why? Well, because I've taken off so many points over the years for students who didn't do that. I don't want to take off points. I want to give points, okay? So, guys, believe it or not, just to give you an illustration of what the difference is, to many of you, probably most of you, I don't know, what I have in y1 and y2 look the same. But that's not the way the calculator sees it. The calculator sees this in y1 is taking 5/3 times x. The calculator sees this in y2 is taking 5 divided by 3x. And those are two different things. Let me go back to the blackboard here, and let me show you why. This versus this is different stuff. I mean, just think when x is equal to 1. This over here gives us 5/3. This over here gives us 5/3. You might say, well, there's no difference. Well, if there's no difference, it has to hold true for all values. If we multiply by 2, we get 10/3. I'm sorry, not multiply by 2, but if we put x equal 2 in for 2 in for x, and if we put 2 in for x over here, we get 5/6. And guys, those are not the same fractions. So it may hold true for one value, maybe two values, but it's not going to hold true for all values, and that's what we need. Okay? Now, let's go back to the to what we have here. Okay? Now, what we need to do is, first of all, I want to get rid of this crap because that's just big old ugly. Now, to do an inequality, what we got to do is we've got to go someplace that most of you probably have never been. That's all the way over to the left. So see where my mouse is circling right here on the screen? You'll see this line flashing. If you go all the way over to the right and hit enter, you'll go through some options. Now that allows you to make your lines really thick. That allows you to create an inequality of greater than or equal. That creates an inequality of less than or equal. This gives us something we don't want. Okay, and that gives us something we don't want. And that brings us back to a light line. And that brings us back to the default. Okay? But we want greater than here. So that's what we need. Now the next thing I want you to do is I want you to go to zoom and go all the way down to the bottom. Well, it's not at the bottom. They've changed it. Then go to zoom fit. Now, if you go to Zoom Fit and hit enter, what it's going to do is it's going to set up your calculator to where you're going to get the best view. Now, I don't really like the way that looks, so I'm going to go in and make a change. And I'm going to go to Window. And I want you to arrange this to understand that you can run this from -10 to 10. And from Y from -10 to 10. Now, why did I choose that? Is that something you should have walked into my class knowing? No, it's not. Sometimes you got to let me teach you stuff. And this is one of those cases. Now, what we've got here, guys, hold up just a second. I just got a text and I need to respond to that. I know you're saying we're not supposed to be texting in class. It won't take long. Chill out. It's too bad I don't have some music or something, isn't it? Okay. All right, just about done. Hang with me. Sorry about that. All right. Thanks for being patient, or at least making me think you're patient. Okay, guys, what happens here is any value that's in the shaded area, any point, is a solution. So it looks like to me this point right here where I'm circling 0, 0 is a solution. So I'm going to grab my blackboard. Hopefully I'm still, hadn't kicked me out yet. So 0, 0 looks like a solution. And it's one of infinitely many. And guys, if I come over here, let's go over 1, 2, 3, 4, 5 units. And come down 1, 2 units. So where I've got the pointer right now is approximately at the point 5, -2. Notice that's not in my shaded area, so that's not going to be part of the solution. Now, if you allow me to go back to the blackboard, I've got that. I've got that 0, 0 was in the shaded area, so it's a solution. And 5, -2 is not a solution. Now, if we go back to our original problem, and I forgot it, so let me bear with me here. 5x minus 3y less than or equal to 15. You'll see when I put this information in that I get 0 minus 0 is definitely less than 15. However, when I put this information in, I get 25 plus 6 is 31. And guys, this is a false statement. 31 is not less than or equal to 15. So guys, any point value that's in the shaded area, any point value that's in the shaded area is a solution, and anything that's not in the shaded area is not a solution. Okay, let's let the fun begin now. Okay, and let me find a. All right, let's take a look at this one. What we want to get into, setting the stage for linear programming problems, is systems of linear inequalities. So we want to be able to solve things like this. And guys, I'll go ahead and tell you, these linear programming problems, when you first see these things, you think, oh my gosh, those things are extreme. They're incredibly insane. I'm not going to be able to do those. You will be able to do these. It's going to be a slow learning curve. But guys, be patient, be persistent, and just hang in there. It's going to happen. Students, I get emails and texts, and somebody sent me a thing on Twitter the other day. Said, I'm taking a class where we're doing linear programming. I didn't think I'd ever learn it, but I prefer your way a lot more than the way I'm being taught. Guys, again, it's going to look like you're going to feel like you're trying to swallow a 500-pound marshmallow in one bite working these things, but you will learn them. Or I think at least most of you will. Hopefully all. So guys, what we're looking for here is we're looking for solutions that make both of these a true statement. So the first thing I want to do is I want to convert these into y equals mx plus b form. So the first one is going to be y less than or equal negative 3x plus 21. And the other one, I've got a little bit of work to do. So I've got negative 2y less than or equal. I've got to move the x over, which makes it a negative x. Now I've got to divide by negative 2. Divide by negative 2. Now that's a little weird looking, but we can make it look like what we want. So these are going to cancel out, as you guys like to say. And ultimately what happens, we have divided by negative numbers, so this thing here has to change. So on the left-hand side we get y, and on the right-hand side we get a negative and a negative, which I would prefer to write as 1/2 x. Now if you just don't like that and you want to say, well, I just want to treat this as x over 2, that's perfectly fine. That'll work. So guys, our two values here are y less than or equal to negative 3x plus 21 and y greater than or equal to 1/2 x. Alright, is everybody cool with this? Alright, now let's go to the calculator. So we got two inequalities that we have to put in now, so it makes it a little bit more difficult, but still doable. So go to y equals. And I want to clear this out, and I'm going to put negative 3x plus 21. And I need to come over and set my inequality, which I'll do in just a second. And I'm going to put 1/2. If I were doing this, I would just put 0.5, but I want you guys to get in a habit of putting your computer's running really slow, guys, so bear with me. Now, what I got to do now is I've got to make sure that I come all the way over here to the inequality stuff. And put in the inequality that I need. Now for the 1/2 x, I need greater than. So I'm going to start clicking until I see my line going up. Alright, cool. Now I'm going to go up to the top one, and I'm going to click my line until I see down, because I need less than or equal to. Now, there's no distinction in your TI-84 calculators, or 83 or 82, whatever you're using, whether or not we do greater than or equal, or less than or equal. Okay? So what we're going to do now is we're going to just hit graph and hope that we get a picture that gives us something that makes sense. If not, we may have to adjust the window. Now, we lucked out here, didn't we? We lucked out that we end up getting a picture that gives us the regions, but I think we'd be a little bit better if we zoomed out a little bit. So let's go in and hit zoom 3. And let's zoom out one time. All right, gives us a little better picture. Now, let me show you what's going on here. You've got 4 regions. All right, first of all, this region over here that I'm in right now that's white, those points over there don't solve either equation. This point right here solves the first equation, or these vertical lines. And up here where I'm solving solves the second one. But what we're interested in is we're looking at the checked region, which solves them both. Now, if we think about it, and again, I hope you can see my line here, if I come over -3 and up 1, is everybody okay with that point being in the checked area? So -3, comma 1. I think any reasonable person would think that. So guys, from our graph, it appears that the point -3, comma 1 is a solution to our system of linear inequalities. All right, let me get my airplay back here. All right, gang. So the point, when we looked at our solution set, and I think, let me go back and take a look at this. The solution set, yeah, it looks something like what I've got on this. So what happened is we have this part, which is lines, and we have this part, which is lines. But this stuff over here was all shaded, checked. So guys, this is our solution. And it was reasonable to me that the point -3, comma 1 was in that. So if we check the point -3, comma 1 will solve both inequalities. But guys, let's check it out. So we have 3 times -3 plus 1. Is that less than or equal to 21? Well, -8 is definitely less than 21, right? Now, if we change that to the second one, which is x minus 2y, less than or equal to 0, if we put in x as -3 and 2 is +1, is that less than or equal to 0? Well, that gives us -5, and that is all less than or equal to 0. All right, so what I want you to do, I'm going to end this video. And what I want you to do before you watch the next video is try the following problem. So what I'll do when I start the next video is I will actually work this problem for you. Okay? So let's choose one a little bit more involved. So let's choose 2x minus y less than or equal to 10, and x plus 2y less than or equal to 8. Okay, so try this, and this will be the first thing that I'll work in the next video. This is going to be a long video. It would have been easily a an hour and 45-minute lecture. So I think I can do it in a little bit less than that. Plus my dog's going absolutely insane on something. But oh well, that's the way it works. All right, guys, have a good one. Work this problem try this problem before you start the second video, and give you a little bit of feedback on how you stand. Guys, there's no getting out of it. You're going to have to be able to work these. And it plays an integral role in working linear programming problems. All right, guys, have a good one. See you soon.